In this video, I'm going to walk you through the steps of calculating Pearson's R. I've got my coffee here. I'm ready to go. Don't worry about it though, it's not going to be hard. I'm going to show you two different formulas for calculating Pearson's R. One is using the sum of products and the other is using z-scores. So we have Pearson's R using the sum of products. When you look at Pearson's R in the world, this is the formula that you're most likely going to see. It's a ratio of the sum of products, which is a measurement of how much the scores vary together, divided by sort of the total variance of the scores in both groups. So it's really looking at a proportion, a relationship. How much do the scores vary together as opposed to how much do they just vary on their own? We're going to walk through this formula later, so it won't make as much sense right now, but I want to just start with a review. What does a linear correlation really mean? So we want to know if the score positions in one distribution and their corresponding score positions in the other distribution vary in any systematic way. So an example, does the amount of coffee people drink relate to the different amount of sleep those people have in any systematic way? So do people who drink more coffee sleep more hours and less coffee sleep less hours, or does it vary in opposite directions? Do people who drink more coffee sleep less hours? Easy for me to say. Okay, so if we have two variables, x and y, there are three possibilities for these linked data. They can be related in one of three ways. It can be that when x is high, y is high, and when x is low, y is low. So this is an example of a positive correlation. We can also have it be the case that when x is high, y is low, and when x is low, y is high, and that is an example of a negative correlation. There's one other possibility. When x is high, nobody knows if y would be high or low, and that is a no correlation. So we really have three different possibilities. So we're talking about position in a distribution. And because we're doing that, we can actually use z-scores in our formula to represent the position of any score. And then we can directly compare the score locations for the two different variables. And this is how we are able to compare apples to apples instead of apples to oranges. X and Y are their own different variables. They have their own different measurement scales. But when we look at them in terms of z-scores, we can then compare them. Well, x is a score of +2 and y is a +2, so they both are high scores, in other words. Let's take a look at the logic of the Pearson product moment correlation coefficient. Remember that we have two equal interval variables or two ratio variables, x and y. And each score in the variable we're going to convert into a z-score to indicate the location of the score is either high in the distribution or low in the distribution. And we're going to define high scores as just positive z-scores. We're going to define low scores as negative z-scores. So if we multiply the z of x by the z of y for each pair of scores, there are four possible results when we do this multiplication. We might have one high x score, we might have one high y score. In other words, two positive scores is going to give us a positive result. If I have a low x score and a low y score, well, the result is still going to be positive, right? Because a negative times a negative gives us a positive. But what if I have a high x score and a low y score? Well, that's going to give us a negative result because I have a positive times a negative is going to give us a negative. And conversely, if I have a low x score and a high y score, and that's going to give us a negative result as well. So think of it this way. 1 and 2 is a positive correlation. This is how we get a positive correlation. It can either be with two high scores paired together or two low scores paired together, but they're varying in the same direction in a systematic way. 3 and 4 is a negative correlation. These are varying in a different direction, but still predictable as one score goes up, but the other score goes down. Okay, this is going to be the formula that I'm going to ask you to use when figuring out correlation, the Pearson's correlation. I have two different formulas here. I have one for the population. This is actually the Greek letter rho, And that's what we use for a population for correlation. And let's take a look and see what it says. It says take the z-score for x times the z-score for y, and then sum up all those products divided by n. Simple enough. And the sample is denoted by the lowercase r, and it's everything the same except for, again, degrees of freedom, n minus 1, to make that adjustment because we don't know the variance in the whole sample. So here we go. This is what we're going to do when we calculate Pearson z-scores, or Pearson r. So here we go. We're going to first calculate the z-score for each score. We need the mean and the standard deviation. We're going to multiply each pair of scores, their z-scores. We're going to sum up those products. We're going to divide it by the n of the population for, or the n of the group for the population, or n minus 1 for a sample. So let's go ahead and try to calculate. If you haven't downloaded the practice sheet, now I highly recommend that you do it. I'm going to demonstrate this in Excel, but this is just, you don't have to use Excel. You could do exactly what I'm doing in Excel on paper. So don't get caught up in the Excel issues. If you hate Excel, just watch it and see how it's done. Okay, so we're going to calculate if coffee consumption is correlated with the amount of sleep. I have everything you need here to calculate a Pearson's R. So I've got some formulas at the bottom, but we're going to be using the population formula for finding Pearson's R. And in order to do that, we need z-scores. So I have the formula for z-scores, but in order to find a z-score, we need standard deviation. So I have the formula for standard deviation. So we're going to be working backwards in a way to finally arrive at this correlation. So let's give it a try. First of all, we have 10 subjects. Each subject has a score of ounces of coffee drank per day, and they have hours of sleep at night. So we want to know if coffee and sleep have a predictable relationship. Do they correlate? So the first thing I'm going to need to do is find the standard deviation. And the first step in finding the standard deviation is finding the mean. We need to know how much each score deviates from the mean. So I'm going to do an equal sign, and I'm going to sum up all of these scores first because I want to find the average. So I'll do that very fast. Equals, and we have 162. To find the average of this, I'm going to do equals 162 divided by 10, and we have an average. So the average of the coffee ounces is 16.20. We need that average in order to find out the standard deviation. So again, this is our formula for standard deviation here. We're going to take each score and subtract the mean of 16.20. And I'm going to take this, I'm going to drag it down. Oh, it included these down here. I don't need to do that. I only want the actual scores, not all of this. So this, if you add it up, it should equal to 0. I'm not going to do that right now. I'm going to trust myself. So here we go. And then we're going to take each score and we're going to square it because remember, we're looking for the sums of squares to find variance and standard deviation. Now we have each score squared. We are going to sum up those squared deviations. So I'm going to add all these up. And to find variance, I take the sum of squared deviations divided by 10 when we're dealing with a population. And to find standard deviation, I'm going to find the square root of that variance. Hopefully this is review for you. If not, you might just want to revisit this a little bit. The square root of the variance is standard deviation. Our standard deviation is 5.23. Okay, so what I'm going to do is I'm going to take the standard deviation and I'm going to put it here. I'm going to paste it as value labels. Okay, so now I have my standard deviation. I have everything right now to find a z-score. The z-score is the score minus the mean divided by the standard deviation. Do you see score minus the mean here and standard deviation here? Easy, easy. We can go equals the score minus the mean divided by the standard deviation, and we can do that for all of them. Now we have z-scores for the coffee scores. Let's take a look. We have a z-score of 12. The mean is 16.20. It has a z of negative 0.8, which means it's below the mean. That makes sense. A coffee score of 24 is quite a bit above the mean. And yes, the corresponding z-score is above the mean. So right now we have z-scores that show where all of these coffee scores would be in a distribution. So now we're going to find the z-scores again for sleep. So in order to do that, I need to sum up all of these sleep scores first. All right. And then I have my n of 10, so the mean of the sleep scores is going to be equal to 74.5 divided by 10. And so the mean of the sleep scores is 7.45. We need this mean in order to start to figure out the sums of squares that can lead us to variance and standard deviation. So I have the sleep score of 8 minus the mean of 7.45. All right, I'm going to do that for all of them. All right, I have my deviation scores. These should all add up to 0. If they don't, it could be because of a rounding thing, I'm not sure, but they should be close to 0. Okay, I'm going to do the deviation scores squared, because remember we're looking for squared deviations. All right, and again we're summing up these deviation scores. I'm adding all these up. And my variance is going to be my sum of squared deviations divided by my n of 10. And my standard deviation is going to be equal to the square root of the variance. We need this standard deviation to go any further. All right, so my standard deviation is going to be 1.40. I'm going to check this standard deviation using an Excel formula. How about that? I'm going to type in STDEV and I find standard deviation for the population. I'll double click on that. I'm going to select my sleep scores and hit enter, and voila, it is exactly, it's not exactly the same because this goes out to some decimals, but it is the same. So we did this correctly. So now what I'm going to do, just like I did before, is I'm going to take, I'm going to grab this standard deviation. Actually, I'm going to do it differently. I'm going to take this, I'm going to copy it, and then I'm going to paste the values. Right click, paste it as values. Okay, so now we have everything we need for the z-scores for this. So we're going to go equals, and okay. So now what we're going to do, now that we have the z-scores for the sleep scores, is we're going to multiply the z-score of one by the z-score of the other. We were asked to do that. So the first z-score times its corresponding z-score, and we're going to drag all of this down. All right. What we're going to do now is we're going to sum all these up. We're summing these z-scores together. And then what we're going to do is we're going to take these z-scores, the sum of these z-scores, and divide it by our n. And we have a correlation of negative 0.67. What does that mean? It's a negative correlation, which means as the scores of one variable go up, the other scores go down. So this is a negative relationship between coffee and sleep, which means that the more coffee you have, the less sleep hours you get. The less coffee you have, the more sleep hours you get. The scores vary, but in different directions, and that's how you calculate a Pearson's R.